Our next speaker is Philip Rathel. Philip Rathel is CTO of Neo4j, the graph database and analytics leader that enabled the ICU to crack the Panama Papers and for NASA to get to Mars 2 years faster. Neo4j enables thousands of organizations worldwide, including most of the Fortune 500, to solve their most pressing and valuable problems through the power of the connections and data. Philip comes from a long career in data and databases. He joined Neo4j in 2012, helping to pioneer the graph database category and creating one of the world's leading database and analytic companies. He is the recent author of the GraphRAG Manifesto and is a frequent speaker and panelist, features this year at events such as GenAI Summit in San Francisco, Collision, the AI Conference, the AI Engineer World's Fair, Big Data Paris, Gartner Data and Analytics Summit Sydney, SAS Annual, and the Wall Street Journal CIO Summit. Welcome, Philip.
Thank you. I'm going to continue down the path that Gopi laid earlier, which is, what would you trust GenAI for? And let's narrow it down and look at just LLMs. So audience participation, would you use an LLM to plan for your 5-year-old daughter's birthday party? Show of hands, this is participatory. All right, get some ideas, like, what should the decorations look like? What kind of party gifts to have? Cool, all right, so fewer of you raised your hands than I would have expected. We have a good skeptical audience here. All right, now another show of hands. How many of you would use it to actually make the decisions, to choose the theme, design the invitations, order the cake, hire the magician? Anyone? Okay, 1, 2, 3, like a few very brave people, but you can easily see how this can go sideways, like delegating whom to invite and all this stuff to the GenAI. Let's turn it to something that looks maybe a little bit more like our work life. So help me design a new supersonic jet. If I want to get some new ideas on Brainstorm, so show of hands. Yeah, still a good number of hands there. Now, how many of you would actually fully delegate any one of these things? Feasibility studies, design development, like hopefully no one, right? But this is where we want to get to. I mean, we keep talking about this technology and seeing these really impressive uses, but ultimately what we want to do is for it to relieve tasks for us entirely, not just partly. So there's a disconnect. You've all seen this meme, I'm sure. What's the difference between ChatGPT and a parrot? And this technology has come a long way in the last 2 years, but when solving high-stakes enterprise problems, we still have a disconnect, and that disconnect includes lack of enterprise domain knowledge, ethical and bias concerns, access to the most recent data, inability to verify answers, and privacy and security challenges. These things are all pretty much still there. So early on, it sure seemed like, post the release of ChatGPT, we were on this exponential curve, but like all exponential curves, they're actually just kind of like a zoom in for an S-curve, which is what we've experienced. And here I've drawn a GenAI go-to-production barrier, which represents the line beyond which enterprise use cases just aren't able to get with this technology alone, with LLMs alone, even with fine-tuning. So why are they hitting a barrier? Well, it's essentially the fact that it's probabilistic, non-deterministic, lacks critical thinking, and it's a black box. If I'm someone at a company who's ultimately going to be the person on the hook, if this thing makes a bad decision, then probably I'm going to require some explanation of where the answer comes from, even if I can reliably get some pretty good answers. So one solution that has evolved over the last 1.5 years, maybe, is RAG with vectors. And that's definitely raised the barrier, which is cool. So more use cases are possible. This solves some of the recency issues, some of the enterprise domain knowledge issues. But nonetheless, even though GenAI is, there are all kinds of predictions about how much money is and will be spent and gained, as of this year, depending on who you're asking, somewhere between 70 and 2 weeks ago, I was on a panel at a Wall Street Journal CIO summit in New York, and one of my co-panelists, who's VP of AI for Databricks, said 90%. So somewhere between 70 and 90% of organizations are stuck with these pilots that look amazing, but then not able to make it to that next level, which is production, which is where we're actually creating value for the world, making money, et cetera. So what's next? Let me get you there by way of analogy. Let's look at the evolution of web search. So this is web search as we know it today. And so why web search? Well, how is GenAI like web search? Well, with web search, you ask a question, some technology operates on a question, returns some text, and we take that text to be knowledge. All right, what about GenAI? You ask a question, some technology operates on the question, returns some text, and we take that text to be knowledge. So let's go with this analogy a little bit. In the early era of web search, you had all these companies, 30 or so, some of whom you'll recognize here, who took on the challenge of indexing the entire World Wide Web and then providing full text search on top of it, which is pretty impressive, right? And then after a time, these technologies all started being gamified and looking very similar to each other until a new entrant came onto the stage, Google. And if you drill down into their press release, what they describe as their secret sauce is actually they took all this text, which actually appears on pages, and those pages are interlinked. They load it into a graph, and they run this graph algorithm called PageRank that operates on the structure of the text to ensure the best results always come up first. They use it to rank their text results. This catapulted the category in a way that now a lot of you who are weren't around at the time have probably never heard of all these companies, right? We pretty much know and use Google. Then in 2012, about a decade later, they disrupted themselves further with something called the knowledge graph. And this is a blog post legendary blog post, let's say, where they describe what they did here is they realized after a decade of using this initial technique where they took the structure of the web as a graph, ran this graph algorithm, that didn't include meaning. And actually, if you want to get to the next level of utility, you need to have some sense of, well, what do these things mean? I'm looking for Rio. I typed in those words. Is it Rio the casino? Is it Rio the city? Is it, et cetera? And so this created another disruption, which lasted another 12 years, where they used the knowledge graph to prioritize and get more fine-grained, better quality results. And I put an end date for this era in 2024 because for anyone who attended the Google I/O keynote, so in the Google I/O keynote, there's this complex question. My family and I are going to Miami for Labor Day, et cetera, et cetera. Kind of, my son loves art. My husband really wants fresh seafood. Can you pull my flight info from Gmail and help plan the weekend? So that's a pretty intricate question that goes beyond probably what you can imagine you can do just with full text structure of the pages and then a knowledge graph. It's very personalized. And the punchline was Google pulled together information, materialized a subgraph coming from this larger world model that they represent as a graph, and feed it to the LLM, and then solve the question that way. And they didn't use the term GraphRAG, but the term GraphRAG has since emerged to describe this technique of pulling data from a graph, taking your meaning, marrying it together with the textual information you have from an LLM and from vectors, and getting better answers. So what seems to be emerging and what we're seeing and others are seeing is that GraphRAG is this next step beyond LLMs fine-tuning and RAG. So what's GraphRAG? It's simply retrieval augmented generation, where on the retrieval path, you include a call to a knowledge graph. There are many sub-patterns and many ways to use it. There are different graphs. There's the lexical graph, which is the graph of structure, think the original PageRank use case. There's the graph of the domain, which is the meaning, the world model. But simply put, it's just calling a knowledge graph as part of a RAG pipeline. And I'll give credit to Microsoft for popularizing the term GraphRAG. They wrote this, Microsoft Research wrote this paper and actually has a whole team called Project GraphRAG. And at the time they came out with this, our customers were already independently discovering this, and we were blogging, and we were calling it just RAG with a graph database. But call it what it is, it's still the same pattern. And you can see this showing up in a bunch of places. So in Jensen's NVIDIA GTC keynote earlier this year, you'll see knowledge graphs listed as one of 3 kinds of data sources on the left. And then Gartner's made some pretty amazing predictions, such as by 2025, which is just around the corner, 50% of generative AI initiatives will use knowledge graphs. Further, Gartner has a GenAI impact radar, and you'll see just 2 things in the dead center, and one of them is knowledge graphs. There's a QR code here with a link to their blog post, which is public. So essentially what I'm saying is GraphRAG is this next S-curve. And what does it look like? So I have an application. That application, you ask a question, you send that question to an embedding generator, you then send a query that will either fulfill a knowledge graph query only or a knowledge graph query with vectors. So many, you could do a call to a separate vector database. We at Neo4j happen to have added vectors as another data type and another kind of index, so you could put them both in the same database management system, both viable options. And then you send that back to the LLM, and your LLM will give you a better answer that also has some level of explainability. Don't have time to get into this during the talk, but you can tune the dial here between full determinism or kind of like graph improved answers, and thereby also turn the dial from white box explainability to gray box explainability. So what's a graph? When I say graph, it's essentially something that looks like this. It's just a way of representing data. So here's a commerce transactions graph where you can see customers buying products which have components and so on. You can see a supply chain easily hanging off of this, or customer hierarchy hanging off of this in the corporate world. Likewise, you have products and parts graphs. We have most of the major auto companies, 3 out of the 5 aircraft manufacturers that have digital twins of their of complex products with 1 million parts and parts of parts of parts, relationships between components and functions, and so on. There's a customer relationship graph. Customer 360 is a great way to actually use the graph to tie back a single master identity to various known ones. And then digital twin is kind of used pretty broadly as a way to represent a real or digital world system as a graph. And in fact, your enterprise is a graph. So each individual part of your company and the way your company interacts, you can represent that as a graph, and many of the world's largest companies do. Let's get into the benefits. So what are the benefits of GraphRAG? We talked about this trend at a higher level, but concretely, it gives you better answers, easier development, and explainability and governance. Let's give an example of better answers. So here is something we use in a workshop that we do with GCP, AWS, and Microsoft. So it's, we're very much, open source minded, and you'll find repos out there with this in the data set if you want to play with it. So it's the Edgar data set from SEC that got ingested into first vectors. So now you're doing a vector-only RAG and answering the question, which asset managers are vulnerable to a lithium shortage against an SEC data set from public company filings? And the answer you get is, it's companies with batteries in their products, companies that manufacture batteries, companies that have dependencies on other kinds of raw materials that get shipped alongside lithium in the supply chain. These are all good answers. They're all accurate, so they pass the accuracy test. However, it's possible to dial in and get an answer that's even higher in quality and usefulness by introducing a knowledge graph. And so here you add GraphRAG to the picture alongside your vector-based RAG, and the answer you get is basically 10 companies. So just think you're an asset manager who's trying to reallocate, assets in your hedge fund based on some news that just hit the wire. This answer compared to the last one, might be, there might be $1 billion difference in quality of answer. Benefit number 2, easier development. So, when we're trying to represent real world data, what we've basically got, so take the human view of an apple is actually much richer than just the visual representation here, right? It has texture and color and, tactile components. But the vector view of an apple looks like this. Like there's not really a lot you can do with it. All you can really do with it is if I have vector for something else, then I can measure the similarity between the two, but then, and then there's no explainability behind it. So it's useful, but it's a bit of a one-trick pony. Whereas the knowledge graph view of the apple, includes information about the system, the network, what's underneath it, and helps, it's a more deterministic, explainable, think of it maybe as a more left brain view rather than spontaneous, reactive right brain sort of view. So the difference between a transparent and explicit representation and only having an implicit and opaque representation makes a pretty big difference when you're developing. So we've gotten lots of feedback from AI engineers and developers saying, look, I fixed a couple bugs thanks to just being able to view the domain graph or even just view the graph of the structure of the documents of this chunk relates to, chunk, next chunk, next chunk, chunk. This chunk comes from this cell in this table on this page in this document that was written by an intern or by a Nobel laureate. Like you might want to treat those a little bit differently, and you can do that with a graph. And last but not least, explainability and governance. You can actually use the graph as a hook for deciding what information you float back or don't out of your enterprise corpus to your LLM. So this is a problem that both LLMs and vectors have, is you can't really, there's no hook with which to apply fine-grained permissions. The graph lets you do that. And then the explainability part is pretty obvious there. All right, because this conference is about AI for all, I'm going to give you some learning resources along with some QR codes. You heard at the beginning, the GraphRAG manifesto. This is a piece that summarizes a lot of what I've talked about and more, and has I'd say the most useful thing about this is at the very end, there's a whole bunch of links to follow-on resources and exercises and learning and so on. So if you capture that, you're capturing along with it like links to 20 or so other things. There's a course on deeplearning.ai that's free, takes about an hour to complete, where you can learn about knowledge graphs and GraphRAG and LLMs. So that's another good one. There's an O'Reilly book that Neo4j has sponsored, put out there for free as an ebook, so you can grab that, called Building Knowledge Graphs, written by 2 of my colleagues. And then last but not least, Graph Academy is another great place to go and just learn about graphs more generally, both from a GenAI and GraphRAG perspective, also more generally in terms of the many other problems that graphs lend themselves to solving. So key takeaway is that knowledge graphs and LLMs go better together. Thanks.